Hello Chem 1A, this is Chapter 4, Lecture Video 7, and in this video we're going to be talking about gas-forming reactions. Now, there are hundreds of different reactions that form gases. We're really just going to be looking at a select few of them. Primarily, we're going to focus on double replacement reactions and when they form gases, and more importantly, about 3 different gases that are formed. So, the whole thing here is going to revolve primarily around these two compounds, carbonic acid and sulfurous acid. You need to remember or memorize that these two compounds, that when they're formed as products, if we make these guys as products, you need to know that they instantaneously decompose. And what that means is that when we form carbonic acid, it almost instantaneously is going to break down into water and CO2 because carbonic acid is extremely unstable under normal atmospheric conditions. So the same thing is true of sulfurous acid. It breaks apart into water and SO2. So when we write products, right, let's say we've done our double replacement, we got carbonic acid plus something else, maybe NaNO3 or something here, right? Well, if we form this guy, we shouldn't leave it here. This is not done because this product doesn't really stick around at all. We should basically, as soon as we see we made this product, erase it and in its place write CO2 gas and H2O liquid. All right, and we'll do some examples of this on the next slide. But the gas we're forming here when we form carbonic acid is obviously CO2. And if we have sulfurous acid formed, we're actually making SO2 gas. So there are some situations where these two compounds are more likely to be formed. And that is if we react anything that contains carbonate with an acid, we will form carbonic acid. That's what these two were, right? But then it breaks down into these two substances. And some ionic compound is the product. If we react bicarbonate with any acids, we're also going to form carbonic acid, and it'll break down into CO2 and H2O. And in addition, we'll also form another ionic compound. If we react sulfite with any acid, we're going to form H2SO3, which will instantaneously break down into SO2 and H2O. And then in addition, we'll also make some ionic compound. The final gas that you need to be made aware of is H2S. So if we react sulfide S2- with an acid, we're going to form H2S. Now H2S doesn't break down, it's not unstable, but it is a gas. All right, when you form H2S at room temperature, it's not going to be a liquid, it's going to be a gas. If you've ever been to a natural hot springs and you smelled that like rotten egg smell, that was H2S. And it's always going to be in the gaseous state. So you just need to remember that when you form H2S, you should be putting the gaseous physical state next to it. Okay, so let's do some practice. So we have Na2CO3 reacting with HCl. Right? This is going to be a double replacement. So the H is going to attach to carbonate, and the Cl, or the Na, is going to attach to Cl. Right? And now when we do this, we know H is +1, carbonate is 2-, right? So the formula we get here is going to be H2CO3. But again, this is carbonic acid, and therefore it immediately decomposes. So I can't leave it like this. I need to basically go, oh, well, that's not going to form. I'm really actually forming H2O, liquid, and CO2 gas. Now, after we do that, we need to do the other product, right? Well, Na and Cl are coming together. So we have Na plus and Cl minus. These two come together as a 1-to-1 ratio. So we get NaCl. It's going to be aqueous because this is an aqueous reaction, and sodium chloride is soluble. So I don't care if you leave this here or you erase it entirely, but it needs to be crossed out because it instantaneously decomposes into water and CO2. And those should be our final products here. All right, let's do another example. In this one, we have the hydrogen attaching to bicarbonate and the sodium attaching to Br. So we get NaBr, just like we did with NaCl. This is going to be aqueous because it's a soluble ionic compound. We know that from the solubility rules. And the other product, again, would be H2CO3. But because that's unstable, we're going to either cross it off or erase it and write H2O, liquid, and CO2, gas. Cool. So let's do these last two. The H is going to attach to sulfite. The potassium is going to attach to nitrate. So we get KNO3 because nitrate and potassium both have a +1 and -1 charge. And we get technically H2SO3, which again, we need to remember, not stable. So either cross it out and write its real products or erase it entirely. I'm going to erase it so that I have more room. And I'm going to write in its place H2O, liquid, and not CO2, but SO2 gas. All right, our final reaction, we have hydrogen attaching to sulfide and lithium attaching to perchlorate. So perchlorate and lithium are both plus and -1. So we just get LiClO4. It's going to be soluble according to solubility rules. And we're also going to get H2S. Now the important thing here is just to remember that H2S is always a gas when we form it. Now I haven't balanced any of these equations, and we definitely would need to do that. So let's go back and balance all these. So in that first one, we notice there are 2 sodiums here and only 1 here. So I'm going to put a 2 in front of NaCl. And this actually comes close to balancing. Right now we have 2 sodiums on both sides, but we only have 2 Cl's on the right. We have 1 Cl on the reactant, so I need to put a 2 here. Now this reaction is balanced. In the second reaction, we have 1 sodium on both sides, we have 1 bromide on both sides, we have 2 hydrogens on both sides, we have 1 carbon on both sides, and we have 3 oxygens on both sides. This reaction is actually already balanced. In this case, we have to put a 2 in front of KNO3 because there are 2 potassiums on the left and only 1 on the right. Now there are 2 on both sides. But now we have 2 nitrates on the right and we need 2 nitrates on the left. So I'm going to put a 2 in front of HNO3, and now this reaction is also balanced. Finally, we have the next equation. We need to put a 2 in front of LiClO4 because there are 2 lithiums on the reactant side and only 1 on the product side. Now there are 2 on both sides. And then finally, we need to put a 2 in between this plus sign and the perchloric acid, to get the 2 perchlorates and the 2 hydrogens on both sides. But these reactions are now balanced. As always, if you have any questions about gas forming reactions, please don't hesitate to come talk to me.